that for you, it is first to draw a circuit diagram in Proteus ICs. Now, do not forget that that circuit diagram must fit the requirements or the purpose of the solution you intend to create or to solve. Why do I keep using the word create? It's solve. It means somebody has told you, design for me a system that does so and so and so. You must have been sure, or you must make sure that whatever circuit diagram you have drawn will solve that problem. Now, since it's in a programming environment, you need to write codes. Codes that you're going to attach to that circuit diagram to run simulation. To write a program, you're going to need a compiler, a CCSC compiler, whether it's a compiler you have or in the IDE you have, or any other compiler for that matter. I didn't say, no. Let me just, okay, maybe at the end of I'm going to mention other compilers that you could use, that will still do the job for you. Are you following me? But for the purpose of our class, we're going to be using what? The CCSC compiler. It is C standard, ANSIC standard language. Okay, so I'm saying that after you've gone to your compiler and then you've written a program, your compiler will generate for you 2 files on successful compilation. Now, and I said it that the fact that a program compiles successfully does not mean that program would work, or when it's attached to your simulation, attached to your circuit diagram, it's going to work. That you have got a successful compilation will mean that you had complied with all the conditions for having a successful compilation, which means you have used the right syntaxes. When I mean right syntaxes, I could say come in English and say wa in Yoruba, and in your language what? Bia. Now we are saying the same thing, but if we are using your language compiler, it will understand bia, will not understand wa or come. If we are using his own compiler, it will have understood wa. If you are using my compiler, it will have been wabi. Do you get it? So what I'm saying in essence is, what we have all said is correct, but in our individual compilers, it will have generated what? A syntax error, because it's not a syntax it doesn't understand. But it does not mean what we have written is wrong. So if we were to use my syntax, or were to use my syntax, we will have written the bia, the wa in the language my compiler understands, and that will have generated a successful compilation program. Are you getting my point? It does not mean that your program is going to work. Understand that. It only means that you have fulfilled all the requirements set down or laid down by the manufacturer of that compiler and the compiler itself. There are several errors it checks, and we'll talk about all of those errors as we continue. So it's going to generate for you several files. Among those files are your .conf file and your .x file. When I mean .conf and .x, this is what I mean. If I named my program at the start and I named it fan control, after successful compilation, I'm going to get fan control.conf, fan control.x. Are you following me? Now, for proper simulation, and so that you can actually simulate properly and see the behavior of the syntaxes you've written in the IC, you would attach the core file to your what? Circuit diagram on ICs. You could attach either of the two, either the core file or the X file, but you use the core file, and later we will see why you use the core file or the X file and where we use them. Let me just say this quickly. When the program is to be burnt into the microcontroller, like when I'm having here, like this is to be burnt into this microcontroller. What you burn into the microcontroller will be the X file, not the core file, the X file. Now on your simulator, on Proteus ICs, you could attach either the X file or the core file. Now if you attach the X file, you won't see what is inside. You won't see what program is executing at any point in time. You can't step into it. You can't debug. That's the word. So it should be draw circuit diagram, simulate, and debug. When I mean debug will mean, let me step into the program. Let me step into it one after the other and see what it does after executing this instruction, what it does after executing that instruction. that is all. Please look up, please. That is what this core file will generate for you, or will offer you. If you attach the core file, you will be able to simulate and you will be able to debug. Debug will mean you will be able to see what syntax in my C is the simulator executing right now, and then you can see the result simultaneously. But if you attach the X file, you won't be able to see the syntax that is executing. It will just be executing. So you can only start that execution or what? Stop the execution. But with the core file, you will be able to see the codes, the commands that your system is executing per time. So it offers you debugging feature. Do you understand? So these two files will be generated, and that's what you actually attach to your circuit diagram on Proteus ICs. Now let's continue. Now, having done that, if you then need to make, say, a physical board like this, it means that, of course, if you look at this board, you see I have the IC seat there. Are you there? So I can simply get the IC and attach, of course, the microcontroller, and attach the microcontroller to the seat. Does it make sense? And then I get my programmer, and through my in-circuit serial programming port, I can transfer from my laptop the hexadecimal file, are you with me, through my programming device into this IC. Does it make sense? That's what I can do. Alright. So if you then need to make physical board like this is what we call the PCB board. If you need to make a physical board like this, then you will then learn or need to transfer your circuit diagram here to the iris environment where you now make PCB board like the one I'm holding. Now, please can you give me one of those PCB? Okay, I have one here. Now, after converting your diagram or your design to iris, what you're actually going to get from it is something like this. This is what you go to print. This is what you then transfer on a copper plate. You've seen the process already. This is what you now transfer on a copper plate. You drill, you etch, and then you plant your component, you do the soldering, and then you can have something like this, with the back looking this way and the front looking this way. Does it make sense? Now, but this will be using the local PCB. If you were to transfer this maybe outside Nigeria or to a PCB company, then what you're going to be transferring will be the GABA file. And with the GABA file, you can then this can then be produced or created for you. So this will be a foreign PCB board, and this will be a local PCB board. Does it make sense? Local, foreign. Local, foreign.
Like the GABA file, is it from the iris?
Yes. From the iris. And there are other softwares that can actually help you from where you can draw circuit diagram and generate or convert to a GABA file, and then send the GABA file. With the GABA file, this will be done for you. You can then come back and do your planting and soldering. You can have them do all of that for you then. But this is what the local PCB will be. This is what the foreign PCB will be. Does it make sense? Be clear?